Have you ever wondered what causes a match to light? Or have you ever thought about how the engine of a lawnmower uses gasoline to turn the cutting blades? Have you ever thought about why salt melts the ice on a sidewalk? Or have you ever wondered why certain metals, such as iron, rust over time? Why do all these things occur? These are all examples of chemical reactions in action. What exactly is a chemical reaction? How do chemical reactions start and finish? And what are some of the different types of chemical reactions? During the next few minutes, we're going to explore these questions and others as we explore the fascinating topic of chemical reactions. Chemical reactions are all around us, even though we may not notice them. A chemical reaction is the process by which substances undergo chemical and physical changes that form new substances with new properties. Let's take a look at an example. When you cook an egg, you're witnessing a chemical reaction. When you sit by a warm fire, you're feeling the result of a chemical reaction. And when you eat, you're fueling your body for a series of chemical reactions that help you survive. Even though chemical reactions occur in many places, they aren't always easy to detect. Here are some clues which may indicate the presence of a chemical reaction. One indicator of a chemical reaction is a change in color. For example, when grayish-colored iron turns a brownish-orange color, it indicates that a chemical reaction called rusting is occurring. Sometimes a chemical reaction produces a gas, as do these antacid pills when mixed with water. Chemical reactions may produce a solid, called a precipitate, which forms when two liquids react. These large solid structures are precipitates formed underwater from chemical reactions when this lake was much higher. Another good indicator of a chemical reaction is a change in temperature. When the chemicals in this match tip are ignited, a chemical reaction is triggered that produces heat. Magnesium, when ignited, also produces a great deal of heat. These are just a few of the indicators which are clues to identifying chemical reactions. When you look at the forest in the winter, you see a much different scene than looking at a similar forest in the summertime. What accounts for this difference? The main difference is that in spring, leaves emerge from trees, shrubs, and other plants, giving the landscape an overall green appearance. You decide. What vital chemical reaction is occurring in this leaf? The important chemical reaction occurring in all these leaves is photosynthesis. In the process of photosynthesis, plants take in carbon dioxide and water. Then, with the sun's energy, they produce oxygen, sugar, and water vapor. In this chemical reaction, plants are able to take several substances and convert them into new substances that help them grow and reproduce. Other animals also benefit from this process. Their bodies use sugars, which they obtain when they eat plants, and they also breathe in oxygen, which plants give off. In chemical reactions, there are two main types of substances: reactants and products. Let's take a look at a simple chemical reaction between baking soda, also called sodium bicarbonate, and vinegar, also called acetic acid. These are called the reactants. Reactants are substances that enter a chemical reaction. When combined, these reactants produce new substances called products. The products in this reaction include sodium acetate, carbon dioxide gas, and water. These are new substances that did not exist before the chemical reaction took place. In a chemical reaction, energy is either released or absorbed. But not all substances that are combined necessarily undergo a chemical reaction. To make a fruit salad, different pieces of fruit are cut up and mixed together. The original kinds of fruit were not changed, and no new substances were formed. When the fruit was mixed, the existing chemical bonds in the fruit were not broken, and so no new bonds were formed. You compute. How would you write out this numerical expression? 3 times 2 equals 6. You would write this expression as a mathematical equation as follows. The number 3 times the number 2 equals the number 6. Reactions between chemicals can also be written in a similar manner. Let's consider the very important chemical reaction occurring in this plant. Photosynthesis is the chemical reaction in which plants take in carbon dioxide and water and with the sun's energy produce sugar and oxygen. Stating this reaction in words is a long, cumbersome process. It's much easier and simpler to write it as a chemical equation. A chemical equation is an expression which uses chemical symbols to represent a chemical reaction. A simplified version of the chemical reaction of photosynthesis is written like this. 6CO2 plus 6H2O produces C6H12O6 plus 6O2. In a chemical equation, various chemical symbols and other symbols are used to represent the reaction. Polished silver usually has a shiny appearance, but when exposed to the air over time, silver turns a dull, dark gray color. This is the result of a chemical reaction between the silver and sulfur compounds in the air. This reaction produces a product called silver sulfide. When chemical reactions occur, the overall mass of the substances reacting does not decrease or increase. In a chemical reaction, the change that occurs involves the rearrangement of atoms, not the production or destruction of matter. This principle is expressed in the law of the conservation of mass. This law states that mass cannot be lost or gained in a chemical reaction. As we discussed, the law of the conservation of mass states that mass is not lost or gained in a chemical reaction. Another way of looking at this law is that the number of atoms of each element must be the same before and after a reaction. This stove in this kitchen burns natural gas to cook food. Natural gas is made up mostly of a compound called methane. When combusted, it reacts with oxygen to produce carbon dioxide and water. The chemical equation can be written as follows. CH4 plus O2 produces CO2 plus H2O. On the left side of the equation, there are 4 atoms of hydrogen, but on the right side, there are only 2 atoms of hydrogen. This chemical equation is not balanced. We need to make it balanced by adding coefficients. A coefficient is a number written in front of chemical elements or compounds. A coefficient indicates the number of atoms or molecules of a substance present in a reaction. To make this equation balanced, all we need to do is add a 2 in front of the O2 on the reactant side, and then add a 2 in front of H2 on the product side of the equation. The equation is now balanced with the same number of atoms of each element on either side of the equation. There are thousands of different chemical reactions. As we mentioned, they're going on all the time around us. Many chemical reactions are constantly occurring in the human body. Scientists often classify chemical reactions to help make the different types easier to understand. While chemical reactions all form products, they differ in the way the products are made. One type of reaction is called a decomposition reaction. A decomposition reaction occurs when a complex substance is broken down into two or more simpler substances. For example, calcium carbonate in this marble can decompose into calcium oxide and carbon dioxide. The opposite of a decomposition reaction is a synthesis reaction. In a synthesis reaction, two or more simple substances combine to form a new complex substance. For example, in the process of rusting, iron and oxygen combine to form iron oxide. In a type of reaction called a single replacement reaction, one element replaces another in a compound. An example of a single replacement reaction occurred when the copper in this copper solution replaced the iron in these nails. You predict. What will happen when we place this copper wire in a solution of silver nitrate? When a copper wire is placed in a solution of silver nitrate, over time, the copper replaces the silver in the nitrate, forming a blue substance called copper nitrate. The chemical equation representing this single replacement reaction is Cu plus AgNO2 produces CuNO2 plus Ag. Notice how the copper replaced the silver in the reaction. In another type of replacement reaction, called a double replacement reaction, different atoms in two different compounds replace each other. When a solute is placed in a solution of silver nitrate, a chemical reaction takes place in which two different elements replace each other and a precipitate is formed. Here, KCl plus AgNO3 produces AgCl plus KNO3. Notice how both potassium and silver replace each other, forming two new compounds. When you fry an egg, a chemical reaction is taking place in the egg. In which pan will the egg cook more quickly? The one in the sunny window or the one on the stove? As you can see, the egg on the stove cooks much faster. Temperature has a big effect on how fast chemical reactions occur. Reaction rate is the speed at which a reaction takes place, or how quickly reactants change into products. A chemical reaction is occurring in these glow sticks. You predict. Which one will be brighter, the one placed in cold water or the one in hot water? After several minutes, the one in the hot water is brighter than the one in cold water. This is because increased temperature speeds up or increases the reaction rate. An increase in temperature makes particles move faster, which forces reactants to collide and react more frequently. Concentration, or the particles present per unit of volume, can also affect reaction rate. For example, as the valve on this stove is turned, the concentration of gas increases and the combustion process increases. In another example, the acid on the left has a lower concentration than the one on the right. When a piece of magnesium is dropped in each test tube, you can see that the one on the right with the higher concentration has a higher reaction rate. You observe. What fire is burning more vigorously? The one with one large piece of wood or the fire with many small pieces? The fire with many small pieces or many small particles is exhibiting a higher reaction rate. Why? This is due to the fact that the many small pieces have a larger surface area. Increasing the surface area increases the rate of reaction. When we chew food, catalysts in our mouth are actively promoting digestion. A catalyst is a substance that increases reaction rate, but itself is not consumed by the reaction. Reactions in our body that might take years to occur are able to occur within seconds due to special types of catalysts called enzymes. During the past few minutes, we've explored some of the fascinating features of chemical reactions. We learned that a chemical reaction is a process in which reactants undergo chemical and physical changes that form new substances called products. We discussed some of the indicators of chemical reactions, including a change in color, the production of a gas, the formation of a precipitate, or a change in temperature. We also explored how chemical reactions can be represented by chemical equations. The process of balancing chemical equations has also been demonstrated. We discussed some of the different types of chemical reactions, including decomposition reactions, in which a complex substance is broken down into two or more simpler substances. We also discussed the opposite of a decomposition reaction, known as a synthesis reaction. In this reaction, two or more simpler substances combine to form a new complex substance. Single and double replacement reactions were also discussed. And finally, we explored some of the factors which influence chemical reaction rates, including temperature, concentration, surface area or particle size, and the presence of catalysts. So, the next time you cook some food, see a roadside flare, or enjoy the warmth of a fire, think about some of the things we discussed during the past few minutes. You just might think about chemical reactions a little differently. Fill in the correct word to complete the sentence. Good luck, and let's get started. Number 1. This chemical reaction is showing a change in. Number 2. The new substances produced in a reaction are the. Number 3. In a reaction, energy is either or absorbed. Number 4. A chemical uses symbols to represent a reaction. Number 5. The law of the conservation of states that mass cannot be lost or gained in a reaction. Number 6. Coefficients can be used to equations. Number 7. This is an example of a reaction. Number 8. In a reaction, two or more simple substances form a new complex substance. Number 9. Reaction is the speed at which a reaction occurs. And number 10. An increase in temperature tends to the reaction rate.